teaching of whole numbers and operations. In the RMK, they write there teaching of numbers and operations. Actually, it's whole numbers and operations. So topic 2 is all about learning whole numbers. Okay, how we teach whole numbers and operations. Okay, we start with number sense. What is number sense? Okay, every child that passes through primary school must develop a good number sense. A good number sense means a good intuition about numbers. When they see a number, they know what it means. That is a good intuition. Okay. Okay. It develops gradually as a result of exploring numbers, visualizing them in a variety of contexts, and relating them in ways that are not limited by traditional algorithms. Okay, so in other words, number sense means understanding numbers, understand ways of representing numbers, understand relationships among numbers and number systems, understand the meanings of operation and how they relate to one another, can compute fluently. That means can do arithmetic, addition, multiplication, subtraction, and so on, can do it fluently and can make reasonable estimates. All children who pass through primary school must develop a good number sense. All of you are already at this stage, you already have a good number sense. As long when you see a number, you know what to do with it, that means you have good number sense. So for example, so if you ask a young child what is 5, okay? If you ask them what is 5, for them 5 can mean 5 digits of your hand, the 5 fingers of your hand, or it can be 5 dots on the top of a dice, or it's 2 plus 3, or 3 more than 2, or it can be 5 crosses, 2 plus 3, or 4 triangles plus 1 triangle, or 5 1-cent coin equals to 5 cents, or it is a half of 10, or they can say 5 is 3 less than 8, or they can show a yellow Cuisenaire rod and say this is 5. Okay, or they can tell you that 5 is the number before 6. Okay, or they can tell you that my telephone number has 3 fives, or the number of letters in my name is 5. If they can represent 5 in many different ways, that means they have a good intuitive sense of 5. This is what you mean by number sense. Okay, you look at the number, you know what it means, what it represents. You can represent it in various ways. That is number sense. So when children pass through primary school, they must live with a good number sense. Okay, whole numbers. The concept of whole numbers develops through several stages. Okay, stage 1 is called pre-numbers. That means there are certain concepts that we must teach children before they learn numbers. Okay, after they go through the stage of pre-numbers, then we teach them early numbers. Numbers is very wide. Okay, there's so many skills that come under the topic of whole numbers. So in the beginning, what are the skills that they need to know? The first few skills, the most important skills, these are called early numbers. And then they need to know place value. Then they learn how to read and write numbers, how to count, okay, how to do rounding. Rounding is just representing numbers in an easy way. Okay, sometimes the numbers are too long. You want to represent easy way, you do the rounding. And children must know how to do operations involving whole numbers. So in order to study whole numbers, they must go through all these stages. They must learn all these concepts. So it's quite a number of concepts that these concepts are spread out from year 1 to year 6. Okay, let's look at the first pre-number concept. If you have any questions, you can stop me anytime and ask me questions, okay? Okay, pre-number concepts. At this stage, children learn the prerequisite skills needed to learn numbers. Anyone can tell me what is prerequisite?
No idea.
Okay, prerequisite is pengetahuan sedia ada. Okay, that means when you want to teach something, the student must know some skills already in order for them to learn that, okay? So when you want to teach numbers, students must already know pre-number concepts. So when they come to class, they must have pre-number concept, then they can learn number. If they don't have the pre-number concept, it is difficult for them to understand and master numbers. So for numbers, the prerequisite is pre-number concept. Okay, pengetahuan sedia adalah. Okay, so there are two pre-number concepts here, classification and pattern recognition. So that means before they can learn numbers, they must learn what are these two things. They don't have to learn the meaning of classification, but they must know how to classify and they must know how to recognize pattern. So it is your duty as a teacher to teach them all these skills before they learn numbers. Usually, children learn this in preschool. Masa prasekolah, they learn this already, okay? But some children don't learn, okay? So they come to class, they don't know this. So it's a good idea to start with this kind of activities first. Okay, what is classifying? Huh? Classification is a prerequisite for counting skills. Yes, if you want to teach counting or if the child wants to learn counting, they must know classification. Because when you ask them how many, first they must classify it, okay? So classification is the ability to separate one thing or object from another. When students classify objects, they may use words such as, these are math vocabulary, yeah? Equal, not equal, more, less, to describe their collection. Okay, this set is more than that set, okay? Or set A and B are equal. We want to encourage them to develop mathematics vocabulary such as equal, not equal, more and less. So before students can answer the question, how many, they must know how to make classification. Okay, the classification process will introduce them to cardinal numbers, which we will see later. Children need to look at the characteristics of different items and find characteristics that are similar. When you want to classify, we always look for characteristics, ciri-ciri. Ciri-ciri yang sama dan tak sama, okay? Similar and non-similar characteristics, okay? So young children usually begin by classifying according to color. So the first activity that you give them to classify usually is involved just separate according to color, red, blue, green, yellow, okay? Before classifying by other attributes. Okay. Among the models that can be used to teach classification are attribute cards if they are 2D, or we call them attribute blocks if they are 3D. And we also use Carroll diagrams and multicolored chips. Okay. Actually, I have bought many sets of attribute blocks for you all to use. Unfortunately, they are all in college and we cannot do it hands-on. Okay. So we'll just do it like this. Okay, let's look at an example of classification. Okay, so this is the first type of classification that you want to teach children. So you give them, say like, say these are chips, huh? These are colored chips. What attribute do you see here? Let's take one chip like this. What ciri-ciri that you see on this chip?
Circle.
Circle, yes.
Circle.
Circle refers to the shape. So
Shape.
one attribute is shape. What else?
Color.
Color. The other
Color.
attribute is color. Do you see any other attribute other than shape and color? No, right?
Size.
Okay, yes, size, correct. Very good. Shape, color, and size. We have three attributes here. Anything else? Okay, let's say there's three attributes. Okay, so if you give the child like this and ask them to classify, when the child looks at all these chips, they can see that all the shapes are the same. They are all circles, okay? And all the sizes are the same size. The only thing that's different here is color. So the child is going to classify this according to color. We ask them to classify and separate it out. Separate all the same color together. Okay. This is what we want the children to do, okay? Okay, classify. Now you can ask how many blue chips. Now the child can tell you blue chips, how many? 2. How many red chips? 4. But if you ask them earlier, very difficult for them to tell you. To answer the question, how many blue chips, they must classify first. Separate everything out according to color, and then only they focus on what your question, how many blue chips, okay? This is the first stage of classification. We classify according to colors or anything, but just using one attribute, okay? Or later, we can do classification using 2 attributes. This is a Carroll diagram. Okay, this table that you see here is known as the Carroll diagram, okay? Carroll diagram was actually invented by Lewis Carroll, and Lewis Carroll is the author of Alice in Wonderland. He's actually a teacher, a mathematics teacher at Oxford University, okay? So he invented this diagram for the purpose of classification, okay? We want to teach children to classify according to 2 attributes. So you see on the right here, there are many shapes, right? So how many different attributes do you see here among the shapes?
Shapes and color.
Shape and color, there are 2 different attributes. So on the top here, we have 2 different shapes, triangle and circle, and we have colors blue and green. So the child can maybe do according to the shape first, okay? Triangle, we try blue triangle, put it here, okay? Shape blue, green, okay? I'm not going to do everything, okay? Like this, okay? So this is according to 2 attributes, shape and color. Carroll diagram teaches children classification according to 2 attributes, okay? So when you teach in class, you have to give the children this kind of activities, okay? So you must have all this kind of chips, like it can be 2D chips that you give them the table and teach them how to classify. Start with 1 attribute and then continue with 2 attributes, and then you can move on to 3 and 4 attributes and so on, okay? Okay. Okay, so we finish with classifying. These are called attribute blocks. We can use this to classify also. It's a very good. Attribute blocks are well known for classification activities. If you look at these attribute blocks, in how many different ways are they different? How many different attributes can you see here? Shape, yes? There are many different shapes that you can see. We can see square, hexagon, triangle. This is a rectangle.
Rectangle.
Yes, circle and so on. What else? What else is it different in?
Color. Size.
Color.
Size, yes, because we can see a big hexagon and a small hexagon, a big square and a small square. So they're also different in terms of size. What else? Anybody can see
Color.
one? Yes, color.
Thickness.
Yes, correct. Thickness. Okay, you can see this square, yellow square is thick, and the blue square is thin. Okay, so this board attribute blocks, they have 4 attributes. Okay, color, shape, size, and thickness. So it's a very good set that we can use to teach classification and also to teach patterns. Okay. If you can also make your own attribute blocks. They have templates in the internet. You can print it out and you can paste them on cardboard and you can make 2D attribute blocks. Okay, if you can even make them thick by pasting on more cardboards. Okay, so the next pre-number concept that we're looking at is pattern recognition. Okay, as you know, I think you've already studied this, that mathematics is a study of patterns. Okay, so when you design, construct, or when you describe patterns, you are doing pattern recognition. Okay, patterns can be based on geometric features such as shape, relational features such as sequence, or physical features such as color, length, and number. Okay, so in the early stages, patterns help students to develop an awareness of numbers, sequences, and counting skills. That's why we have to teach them to recognize patterns, because by looking at patterns and recognizing patterns, they learn about numbers, they learn about sequence, and they also develop their counting skills. At this stage, children have not mastered counting yet, okay? But they learn the pre-counting skills when they do pattern recognition, okay? For example, like you see in the picture on the left, what comes next, okay? You can be, if you had a 2D arrow, then we can move it and show them the patterns, okay? So they can move and see for themselves what comes next. Or in the second picture, when they look at the picture, it's like 2 greens followed by 1 yellow, 2 greens followed by 1 yellow. They learn a little bit about counting. Here is where counting develops, okay? So pattern recognition and classification are two very important pre-number concepts that must be mastered before you can start to teach them numbers. Okay, so after finishing pre-numbers, now we go on to early numbers. Early numbers means the first few concepts that we want to teach when we start to teach numbers, okay? And these are the most important concepts. At this stage, children will learn one-to-one correspondence. They learn 4 concepts, comparison, group recognition, or subitizing. Subitizing is the term for group recognition, okay? And conservation. So these 4 concepts has to be taught immediately after they learn pre-numbers, okay? Before you teach them anything else, before they learn counting, before they learn how to read and write numbers, they must learn these 4 concepts, okay? So let's look at one-to-one correspondence first. One-to-one. So when we say one-to-one, we always think of matching, okay? In mathematics, one-to-one correspondence refers to a situation in which members of one set can be evenly matched with members of the second set. Okay? To teach one-to-one correspondence, we always use matching activities, one-to-one matching. So you see in the first picture, we have ladybugs here, beetles. We have beetles and ladybird beetles, and we have leaves here. So we have 3 ladybird beetles and we have 3 green leaves here. So we have a match, one-to-one matching. Each beetle gets 1 leaf. And the second picture, there are 5 dogs here and we have 5 bones here. Each dog gets 1 bone. Okay, so 1-to-1 match. Okay, 1 dog, 1 bone, 1 dog, 1 bone. If you were teaching this in class, of course, you can use pictures. You need to move the pictures. You have a dog there and you move the bone to the dog. Second dog there, you move the second bone to the dog to show the concept of one-to-one. Okay, so this concept must be developed before they can learn counting. Second concept is comparing. Children look at items and compare. Because they want to understand the difference. Okay, they use vocabulary like big or little, hot, cold, smooth, rough, tall, short, heavy, light. These are opposite words, okay? So these are comparison words, okay? For maths, we always use more, less, little, big, that kind of things, okay? At the preschool level, children should make comparisons of more, less, and same by making visual comparisons, okay? They look at the picture and they must tell you which is more, which is less. Comparisons can be made to determine more than, bigger than, greater than, less than, smaller than, fewer than. These are all the vocabulary that must be introduced when they make comparisons. So when you teach comparisons, at the end of that activity, they have to be familiar with all these words. They must be able to say set A is more than set B, okay? Using comparison terms like this is important when children are looking for a relationship between 2 or more quantities, okay? So initially, at the initial stage of comparison, we need to teach children how to construct and compare sets of concrete objects, okay? So when you first start teaching them any activity, actually, use concrete first and then only go on to pictures. Okay, these are examples of comparison activities. I see there are 2 pictures here. The first picture of these animals here, if you look at both the picture and ask them to compare, just by looking like that, it's very difficult for the child to compare, because the number of the lion and deer, the number of lions and deers are almost similar, okay, very near. So it's very difficult for the child to compare just by looking. So to do this comparison, if you're using small number of objects, then you must move them, okay. You must move one lion, match one deer. Second lion, match with the second deer. So you need to do one-to-one comparison, okay, one-to-one correspondence through matching to show them which is more, okay. So the better way is to use pictures or objects that are vastly different. You see the second picture of coins, you see the picture on the left, only a few coins, and the picture on the right, so many. One look and the child can tell you that the picture on the right is more, okay. Picture B is more than picture A, they can tell you straight away. So when we start doing comparison activities, we use these kind of examples first, where one look they can tell you which is more. Once you finish that, and then only you do the second kind of comparison, where the number of objects are small. And to compare, we use one-to-one correspondence or matching to compare, okay. So that is the other number concept that must be taught. So far we've done two already, one-to-one correspondence and comparing. After teaching these two, then you need to teach group recognition or subitizing, okay. Okay, in this concept, we want students to automatically recognize a pattern for a given quantity, not too much, but we want students to automatically recognize a pattern for a given quantity, okay? Mathematicians call this subitizing. It is a fundamental skill in the development of children's understanding of number, okay? Instant recognition of a pattern without counting, that is subitizing, okay? You look at the dots, you know how many there. You look at the number of fingers shown and you know how many there is. You don't have to count one by one, okay? So we want children to be able to automatically recognize the number in a pattern. Okay, subitizing helps children to see small collections as one unit, okay? And it's also the basis for counting, okay? Why do we want to teach subitizing? Because it saves time when you're doing mathematics, okay? When you're counting, when you see the pattern already, you can start to count on. You don't have to count every single thing one by one, okay? So it saves time when you do mathematics, especially when you do addition, okay? It is more accurate. It develops more advanced counting skills like counting on, skip counting. All these are based on this, being your ability to subitize. It accelerates the development of addition and subtraction skills, okay? The examples of subitizing using dots. Okay, so you want to show the child this dot here. Okay, you want to show the child the dot. When they see the dot, straight away they must tell you it's 5. Okay, the picture on the left, when they look at the dot, they must tell you it's 5. The picture on the right, look at it once, you must know it is 8. So as a teacher, to teach this, you can prepare flashcards like this, okay, and show them. First, you can go slowly. After that, you go fast, and they must tell you what is the number without counting. You must make sure they don't count. So that's why you must go fast. They must be able to tell you without counting. At least 1 to 9 in primary school, they must know already. Okay? And these are other examples. These are examples using your fingers. We use dots, we use fingers. Also, the other thing that we use are dominoes. Okay, these are dominoes. We can use dominoes to teach children to subitize. Okay, as you keep using it, straight away they look at it, they can tell you this is 6, this is 5. They don't have to count 1, 2, 3. Okay, so that is subitizing or group recognition. Okay, so we've finished 3. So we've seen one-to-one correspondence, comparing, and subitizing or group recognition. Now is conservation. Okay. Conservation is the principle that a given object or quantity remains the same, although its configuration or position changes, or it may be divided in certain ways. Okay. Children 5 years of age and under, they cannot conserve numbers. Okay. Some children come to school also cannot conserve numbers. Okay. They are not aware that moving objects in a set does not change the number of objects in a set. Okay? For them, the quantity of object varies and depends on the arrangement and configuration. Okay? They believe stretching a row of objects makes the row longer, and therefore the number of objects are more. If you have 6 objects, say if you have 6 chairs in one row, and you stretch the chairs, create more space between the chairs and ask them how many chairs, they will tell you is more than 6. If they tell you is more than 6 is many, that means they have not mastered conservation yet. Okay. Okay, this is Piaget's most popular conservation experimenter, where he put 6 balls in a row here, 6 pennies, 6 pennies in a row, 2 rows, and asked them under the original presentation, ask them how many pennies are there in row 1, they say 6, how many pennies are there in row 2, 6, which row has more, and the children say same. Okay, but later the second row, he brought the pennies closer together, and he asked them now which row has more, and they said the first row. So children who can't tell you that the number is the same, they have not conserved numbers yet. Okay, so by the time children leave primary school, they must be able to conserve numbers. In fact, actually, when they come into primary school itself, they must be able to conserve numbers. So as a teacher, you must watch when the children are doing activities, whether they can conserve or cannot conserve. If they cannot conserve numbers, then you must give them extra work to help them to master conservation of numbers. Okay. Okay.